Well, so the premise here is that we're going to make it rain on top of the soil, and we're going to watch what happens, right? And this creates some level of rainfall that I forget, but do you remember? It's
I think it's 2 inches per hour.
Oh, just quite a bit.
Yeah. So
we've had more, but this is it's a good rain event. So we, really are looking for soils that can absorb that level of impact, right? Not that one. Plus, it just got these soils have had 8 inches of water.
Yeah.
So
this is the fourth
the
time.
last group. So this is really like this summer. More or less,
exactly.
Right?
This is a July rainstorm.
Yeah, exactly.
Wow, that second one. The second one really infiltrating.
Right? Right, so they were all taken from different places, different sort of systems, so you can kind of look at that.
Okay, annual crop with residue perennial.
What was the second one?
Annual crop.
That one's with residue.
Yes.
That one's annual, that one's on the road.
And this one was just kind of like on the edge of the road.
Yep.
So, yeah, what we're trying to do is demonstrate how management affects infiltration and runoff. So try to pick, when you're doing these samples, or collecting these samples, try to pick something that is going to have some differentiation. And in spite of the 8 inches of rain that these have gotten, they're still kind of acting the way we want them to, where we see an awful lot of surface runoff and not an awful lot of infiltration.
Comparing not only...
That one had water in it to begin with.
It did?
It did have a little bit.
Oopsie.
Okay. But yeah, not only comparing the color of the water, but also which container it went into is very important, and comparing that across the table there. Did it go, into this one or not? But a system that has, water that catches a lot of sediment means that it has less aggregates really holding those sediments, those particles together. So as the water runs through it, it catches all the particles, runs out dirty. And that's if it goes through the soil. If it can't even penetrate the soil and it runs off immediately and is still running dirty, it means it hit that topsoil, taking all those particles, running away. But if you are able to get through the soil, is it coming out clean? But if you compare, even after 8 inches of rain, you can see the difference in these two colors. This one's darker, this one's still clearer. This is, crop residue. What is it?
It's annual crop.
Annual crop. And this is some really, intense density perennial grass. Just looking at those differences there, it can really, it's pretty effective for people to look at, to see. You can do it multiple times. I bet we could do this like 2 or 3 more times. We would still see a difference between these colorations, if not more than that. It is really a good demonstration. The first time I saw it was with lake lessons we did with Lake Champlain partners, Mrs. Gable, my bad. And we were doing it with kids that are in like 4th grade. It's very easy concepts, really good demonstration. Yeah.
But if you have an outreach event, just reach out to NRCS. We can show up with our trailer. We also have a tunnel, which soil tunnel for kids. The demonstration is, we've done it everywhere from breakfast on the farm to county fairs to community garden events. So it is really a great demonstration of how important soil health is. So.
Yeah. We had. Sorry, go ahead.
I was just saying, I love it.
We had a really good question earlier about, the difference in, plant residue at the surface. Like, can just, dead plant residue that's at the surface, have the same effect as living plant residue that's also been terminated at the surface. And so the difference between those is really what's going on slightly underground. If you just have dead plant residue on top, there's no living roots going through the soil, as opposed to like with the live residue that's just been terminated with, like, say, a roller crimper or been cut or something like that. You still have those living roots underneath. Maybe they're not living or going to be living for long, but they have been through root exudates, have been expelling and creating aggregation. And it's been really helping, and that allows for the water to really go through, most likely clean, as opposed to maybe some different types of aggregation where it would catch more sediment going through.
One thing that, it's cold out and dreary, so it's hard to even think about this, but, think about what would happen to this once the sun came out, right? And it was hot. There's no cover there, and it's already kind of mushed, right? So when you have really strong aggregates, they can resist some of the impact of rainfall if they're really strong. When they're not, like Charles was saying, especially if there's no residue there, it hits the ground, and it's like a huge force. Have you ever been outside when it was raining really hard and you went, ouch, ouch? Okay, think about being a tiny little soil particle, and the rain's coming out of the sky, and it hits the ground, and it's like being hit with the, did this as a demo, like boom, like onto the ground, and there's nothing to, like, this is a dead blow hammer, that's why there's plastic, right? It like to bounce back that raindrop, but when you have that residue, it helps to sort of break the force. But the aggregates do too, if they're strong enough. When they're not strong, they just burst, and then everything separates. And then the water runs off, and it sort of like smears. And then when the hot sun comes out, it just bakes like a, flat pancake. And then when it rains again, it's trying to get into the ground, but it's just flat like cement. And it just then gets even worse, right? And when you think about those clay soils that we have a lot of, like down in Akin County, once that bakes shut, you can get a little shovel and pry up 2 inches, and it's nothing but wet, gooky mud underneath. And, then it takes weeks to dry out enough to go back in and do anything. So the power of the aggregate, I feel like we should make a movie about this. Yeah. The power of the aggregate is, it helps to withstand the pressures of the rainfall and the climate, especially as it's getting more severe, and protects the crops. And I remember a farmer telling me one time that they really wanted to get more of those. When we did this demonstration for them and we talked about that, they're like, I need to get more of those aggregates. How am I going to get more of those? I need more of those, because that kind of soil makes you money, right? It doesn't cost you. I mean, you can easily go out of business with soil that is poorly aggregated in the climate that we have today. So this is one of the most critical pieces to soil health. And, how do we always have a soil that is able to drain water when we get a lot of rain, but also able to retain it when we don't, right? And then keeps the soil covered. See how nice that is? So that it stays cooler when it's super hot, but it also stays a little bit warmer when it's really cold. And we brought this up, when you go outside in the middle of the winter and you're like around a tree and there's no snow there, and there's almost like green grass growing. How the hell is that possible?
Biology.
Right. So, that's the kind of environment we're trying to create, and you have to have living roots, organic matter, etc. to do that. Okay. We got to do our next thing.
Yeah, we have, we're kind of running out of samples here, but so the slake test is where you dump an aggregate into water, and if it's really well aggregated, the water will rush into the pore spaces, and the glues will hold that aggregate together and withstand the outward pressure of the water and not disintegrate. We really don't have any good samples that are demonstrating that here. Part of the problem with our soils here is that because they're so finely textured, we have a lot of silts and clays in these soils here, and because of the fine texture, the water really isn't able to penetrate all the way through this aggregate. I'm going to try this anyway and see what happens. But ideally what happens is that when you have, and see, this is actually going to turn out to be just fine. If this were poorly aggregated, the water would be coming out, and if it were really poorly aggregated, it would also be coming out dirty. You'd be seeing fine sediment coming out along with the water. It's starting to come out a little bit, and it's coming out dirty. I think the reason that it's holding water so well is because of the fine texture, so that it's being held by the silt and clay that are in this soil type, as opposed to well aggregated from biological organisms, because if that were the case, then anything running out would be cleaned. You wouldn't see any sediment coming out at all. I'm going to just try one more, and this is from the roadside. This is probably going to be a huge mess, but I'm going to do it anyway, just for the hell of it. I can even see rocks in this one. So that's really an indication of it's called the slump test, and you can see it's not even really sticking together, it's just running off. It's not holding its shape, and it's also dirty. So there's no aggregation here at all. It's just turning into soup.
puddle.
Exactly. Yeah. So maybe that wasn't an okay sample to use.
It's a poor aggregation, and we had a great person ask a great question about, like, well, what, if you had a sandy one that have great aggregation. Two very different things. There's texture, and then there's aggregation. You can have poor aggregation in fine and coarse texture, and you can have great aggregation in fine and coarse texture things. So those are two very different things. Aggregation is the glue that forms the structure of the soil. Aggregation is, the ability of soil to have a diversity of pore space, pore sizes, and things like that. So, thank you all so much for listening. I think we're going to go do our wrap up. Yep, it's past time. Thank you all so much for doing all this. Thanks. You don't want to know.